To cope with the implementation difficulty, we made the following preparations, which were later found to be necessary. First, establish an overall coordination mechanism to implement IPv6 deployment requirement into the construction projects of each department. Establish a user complaint feedback mechanism to conduct various issues during the IPv6 deployment. Second, form an industrial internet platform team to research and release various industrial policies. Establish an IPv6 lab to develop technical solutions and address any unforeseen problems that may arise. In the government policy, we have issued a series of supporting measures to promote IPv6 at the city level. In terms of technical means, city level IPv4 interconnection system has been used to address issues related to application compatibility, network resource management, and deployment monitoring. For publicity, the initiative has been promoted to the public and business through various channels, including organizing the connection of future city in the Shanghai series competition. Next, I will talk about the practical of IPv6 only deployment from city public service and enterprise deployment, home IoT appliance and personal applications. For city public services such as roads, schools, hospitals, parks, and communities, we have required that all the networks, systems, and terminals all support IPv6 only. Currently, all networks already support IPv6 only. For systems that do not support IPv6, the modification cost is relatively high. And to address this situation, we use translation technology to achieve it. For terminal products, the terminals that do not support IPv6 are replaced in batch. Some terminals, such as water and electricity meters, do not have replacement. We develop new products that support IPv6 with manufacturers. For enterprise deployment, we provide IPv6 only dedicated lines to ensure all enterprise traffic is IPv6. Within the enterprise, those that are permitted with translation technology used for accessing external IPv4 resource. A specialized team from lab and operations is available to support the enterprise in implementing the IPv6 only and address issues encountered with application compatibility. We also offer subsidies policies to help reduce the cost associated with adopting IPv6. Simultaneously, we leverage national resources to encourage major application providers like Tencent and Alibaba to enhance their IPv6 support. is mainly concentrated in 4 aspects. Access means home gateways, home application, and home IoT devices. At present in Shanghai, operator have the capability of IPv6 only access and just need to enable. About 10% home gateways do not support the IPv6. Government and operators are implementing an for new service to encourage users to replace their non-IPv6 home gateways. For home applications, translation technology is used to achieve the interconnection of different protocols. For home IoT devices that do not support the IPv6, the design access solution is adopted to ensure that they can integrate into the new network environment. For personal applications, the focus is in 4 aspects: mobile public networks, mobile terminals, mobile apps, and service platforms. In Shanghai, mobile public networks have been complete IPv6 only deployment. Mobile terminals that do not support IPv6 are not allowed to sold. Mobile applications that do not support IPv6 are not allowed to go online. For the non-IPv6 service platform, we use translation technology to achieve IPv6 only deployment. The following example of IPv6 only deployment in Shanghai, including IPv6 digital works, our lab office, and tenant apartments. Various sensor and communication devices installed on multifunctional poles, such as lidars, cameras, and RSUs, are all carried through IPv6 only networks, supporting the low latency requirement of vehicle-based cooperating service. At present, the total mileage of digital growth in Shanghai has reached 153 kilometers, and the construction scale covers 12.7 square kilometers. It is the largest digital world experimental area in the world. The office network in our lab consists of router, switch, and network interconnection system. That's 64 plus ALG. These network devices are deployed in the doorstep areas. The office computer and OA servers are deployed in the IPv6 only area, communicating with external IPv4 network nodes through the network protocol translating equipment, the network interconnection system. A few non-IPv6 devices, such as access control system and all printers, are deployed in those area, connecting public network with DS lines. So far, our network is running well. We create an IPv6 home application scenario in Shanghai government's tenant apartments. Home IoT devices in apartments, such as air conditioners, TV sets, lamps, curtains, are all carried on IPv6 only home levels. When these devices are powered on, they automatically search and connect to internet through the built-in IPv6 network module. So far, 2,500 apartments have been assembled. From this example of IPv6 only deployment in Shanghai, we found that it is difficult for individuals or groups to complete this work alone. Indeed, mandatory interventions from the government to establish an effective work coordination mechanism. A dedicated support team is needed to solve various unforeseen problems. A good collaborative industry ecosystem needs to be established to provide product support. Although the upfront cost of the IPv6 only deployment is higher, the final payment cost is lower. Finally, it's necessary to do a good job of publicity and win the support of the public to sustain completion. In conclusion, IPv6 only is not impossible. Thank you.
Okay, right. Thank you. Thank you. So I will shift over QA to final if you still have time. So I'd like to thank you, Bo Yang. And finally, I'd like to invite the last speaker, his participant remote. Is Zhang Wei from Tsinghua University. He's going to give an introduction on comprehensive analysis and measurement on IPv6 interface pattern. Let's welcome Zhang Wei from Tsinghua University. Can you hear us?
Yes, can you hear?
Yes, loud and clear.
Okay. Good morning, everyone. Today I will be presenting our recent work, Comprehensive Measurement of IPv6 Address Interface Identifier Pattern in Current IPv6 Deployments. This study offers insights into how IPv6 interface identifiers are assigned and discusses the implication for IPv6 address scanning and user privacy. Here's the outline for today's presentation. We'll start with background on IPv6 interface identifiers, followed by the motivation behind this study. I'll then explain our method covering data collection and pattern recognition. For data collection, we use public mailing list as a new IPv6 address data source for the first time. For pattern recognition, we introduce a novel random address recognition method. Next, we'll look at the results, highlighting the patterns and trends we observed. And finally, I'll conclude with a summary of our key findings.